Hello, students. We've got a couple questions out of 7.2. Looks like we have 14, 19, 23, 24, 30, and MC number 6. So let's take a look. So as we start this off, we will have 14. This question, so I'm going to scroll down here to the bottom. 14. Which of the following result in equal quotients? Now, this is something we talked about today, basically floffing. So that's really all you're doing here. So again, if you wanted to think of floff as let's see here, 2 over 5, and then you multiply top and bottom by a single number, and you might end up with multiplied by 3, you get 6 over 15. But you could rewrite each of these as division. We could say 2 divided by 5, and that's going to be equal to 6 divided by 15. And because these are division problems, we're really looking at the quotient here. So these are known as equal quotients. So if you floff both numbers, kind of use the fundamental law of fractions, you'll get things that are equal. So if you had 9 divided by 0.35, is that the same as, look at the next one, 90? So think about it, you multiplied by 10. If I was floffing, I'd have to multiply this one by 10. So I'd have to say divided by 3.5. Is that what we have? And I'd be like, oh, heck yes. So right now, 1 and 2, those represent equal quotients. Check it again with the next one. Is that equal to the same thing? Okay. And you could check it again with the fourth one, but this time you're kind of going down. So maybe you're multiplying by 1/10, or if you prefer, dividing by 10, but it's the same concept. Fundamental law of fractions. It is following us everywhere. Gotta love it. Okay. So that is question, let's see here, what was it? 14. Next up is 19. So let's clear the drawings and head up to question 19. Keith bought 30 pounds of nuts at 3 pounds, $3 a pound, 20 pounds of nuts at $5 a pound. He wanted to buy 10 more pounds to make the average price per pound equal to 450. All right. So yeah, I mean, if this was you kind of doing the problem, perhaps you're looking at, I have no idea how much, how much more he should pay for 10 additional pounds. So you could write it out. So you could do this problem algebraically. And that's, again, why we have that prerequisite in place, right? Make sure you've got a little bit of algebra skill as you're going through, which means you just understand how to deal with unknowns. So if you don't know how to do this problem, put in the missing piece, and then you can work forward as if you did. If you are really struggling with this problem, we'll talk a little about a different approach after showing this. So we have 30 pounds of nuts at $3 a pound. Okay. And so that's 30 pounds times $3 per pound. So the pounds are going to go away. And so really, I've got $90 that I've spent so far. I also have 30 pounds of nuts, right? Okay. And then I got 20 pounds of nuts at $5. Whew. A little bit pricier. And so the pounds cancel, and I end up with $100 here, but I only paid for 20 pounds. That's again that increase in price. So I want the average price. I want to buy 10 more pounds. 10 more pounds times something. I don't know how much I want them to cost. So the end result will just be 10x. And notice over here, total amount of nuts would be 30, 20, and 10, which would be 60 pounds. And I want to make the average price per pound 450. So you could kind of say, yeah, I have no idea how many I need to buy to make the average 450, but the average would be total money over total pounds. And that's how I could find my average. Well, I know I've got 60 pounds, right? The question is, I have no idea how much I need that dollar amount to be for the total that I spend on 60 pounds. But I know I want that to equal $4.50 because I want the average price per pound. I need this to equal 450. So if you look at this algebraically, you have some number divided by 60 equals 450. So yeah, multiply both sides by 60. And you could say, okay, well, 60 times 450. And again, I know that's kind of hard to do, so I'm going to use the equal products. So I'm going to double 1. So this would be the same. 450 doubled is 9. And then take half of this one. Why? Because it's probably easier to do in my head this way, and I don't need to grab a calculator every single time. Could you multiply this out? Of course you could. All I'm saying is you could also double one, take half of the other, and it might be just even easier because 9 times 3 is 27. So I know I end up with 270. Okay. So that's how much money I have to spend on nuts because I want to get 60 pounds, 270. Come up here and think to yourself, I've already used 100. I've already used another 90. So if you take away $190, you end up with the amount you need to spend, which is 80. Now you can only buy 10 pounds. You need to spend $80 though. How much per pound? And that's kind of the way that you can go about figuring out the average or the amount you want to pay per pound of the other one. Okay. Now, if you had really no idea how to do this, at least stop for a second and say, well, with 30 pounds and $3 a pound, I'm going to spend $90. And for 20 pounds and $5 a pound, I'm going to spend $100. So right there, think about it. You have spent $190, but you did end up with 50 pounds, which is the same as 19 divided by 5. Well, 20 divided by 5 would be 4, right? So this is a little bit less than that. This is 1/5 less. So we get 3 4/5. We're turning this into decimals. So this would be 3 8/10, which is 3.80. So now take a look at this. What are we really saying? If we only bought the first two, you bought quite a few at $3 a pound and a little bit less at $5 a pound. So the $5 a pound is like the ratios. It's going to raise the overall amount that you are paying, but you bought less of them. So if you had bought equal amounts, like if you bought 30 pounds and 30 pounds, if you did, then you're not going to be surprised, but the average amount is going to be dead center. It's going to be basically the average price. But we didn't. We bought less of the more expensive one. So that means there's more of the lower priced one, which is going to bring the price down a little bit. Instead of being $4 right on the nose, it's going to be a little bit less. So now when you think about it here, if I want my average price to be $4.50 a pound, I had better start buying some pretty expensive nuts because I've already got 50 pounds here and I need to bring that average up to $4.50. So I'm going to need something well over $5 because another 10 at $5 would mean we're right at 4. I need to get an extra 50 cents. And that's where we can kind of go, oh, okay, how much can I actually use? Okay. All right, there's number 19. And I believe the next one was 23. So let's see here, clear all drawings. So question 23 is, let's see here, Juliet has 7.11 pounds of candy. She puts the candy into 9 jars. How much candy will be in each jar? This is division. Yeah. So let's just say you had 20 pounds of candy and you were going to put it all into 5 jars. How much in each jar? So how much in one jar? This is the partition problem, if you will, because you have five plates. You want to know how much is on one plate. And so, yeah, it's really just 20 divided by 5 here, which would be 4 pounds per plate or per jar in this case. So, yeah. So yours, take the 7.11 and you divide by 9. And you can use we're in the decimal section, so you can use the decimal division. And because the whole number is already 9, just do 9 divide into 7.11. Don't forget your decimal place is already home before you really get going. Just go one step at a time. Okay. How much candy will each jar contain? We're going to talk about a certain amount of pounds. And it's not 1 pound, because 1 pound, if you had 9 jars and 1 pound in each, that'd be 9 pounds. You have less than that. So it's got to be less than a pound going into each one. All right. Let's see here. We got question 24. Let's see here. Yeah, this is all about kind of thinking about your resulting value and kind of understanding how that works with a whole number. Because usually, like if you go to a pizza restaurant, they often don't let you buy just half of a pizza. It's like buy a pizza, or you can like buy a slice of pizza. And so if you're buying from a place that only sells whole pizzas, you have to decide how many can you buy. So I'll do this one. I think I talked about part A in the video. So each pizza costs $12. $12 times, I don't know how many, but I've only got $80. So when you do this, you will end up with 80 over 12 because you're dividing. And then just go ahead and divide it in. I see what, a 4 in each of them. So a 4 into each would be 20 here. A 4 into the each would be a 3 here. So I have 20 thirds. And if you kind of turn that back into a mixed number, that becomes what, 6 and 2/3. But now go up to the front of the cashier and say, I'd like 6 and 2/3 pizzas. They're going to be like, no, no, I'm sorry. We sell whole pizzas. So how many whole pizzas can he actually buy? And your answer with estimation would be kind of it's the numbers between 6 and 7. So would you choose 6 pizzas that he can buy for $80, or do you think he can buy 7 pizzas for $80? Okay. So you have to pick one of those. That's the idea here. Right. Let's see here. Last one here is number 30. Let's take a look at that. Number 30, multiply each number by 0.001 using mental computation. And so I think this is something that I hope as we kind of get further into this class that more of this becomes like, ooh, I want to know how to do more of it. Let's see. So let's just start with something like this. If you had 5,280 and you multiplied by 1, you know you're going to get 5,280. If you have 5,280 and you multiply by 0.1, remember 0.1 is the same as 1/10. So really, what you could also represent this as you could say this is just like dividing by 10. So this becomes 5280 over 10. They each have a common factor of 10. My answer becomes 528. So I want you to notice as I moved this direction, I've kind of divided by 10. And what happened over here is I end up dividing by 10. So we'll do one more just to kind of get you to that stage. And then I think from that point on, you'll probably be okay multiplying, but let me know. So this one, 0.1. So now I'm going to say what happens when I multiply by 0.01. Okay. Well, 0.01, you can think of this as 1 over 100. 1 over 100 becomes 2 decimal places. And so I would end up writing this as 52.80. Okay. Now for the prior one, you could have also written it with the entire number, 5280, and just remembered I need 1 decimal place because that's the denominator. So you can either divide it in and simplify, or you can just think of multiplying by those fractional pieces. Okay, so the question for you is now what happens when I multiply each number by 0.001. I'm kind of showing a nice little way to think about it here, and I hope that takes care of it. Again, every one of them in number 30 is 0.01. Okay. Let's see here, last call, and lastly, multiple math connections. And let's see here. Number 6. Is the product of two positive decimals, each less than 1, is it always less than each of the decimals? Well, I mean, anytime you encounter a problem like this, or if you see something like this on an exam, just take some numbers and try to see. We have the product, so we know we're dealing with multiplication. And the product of two decimal numbers, so let's see here, 0.2. And I want to multiply that by a 0.3, just as an example. And what do we end up with? Well, using our multiplication components, 0.2, 0.3, I line them up. 3 times 2 is 6. I get one decimal place here, one decimal place here. That's 2 total. And I would move backwards 2 decimal places. So my final result would be 0.06. Now take a look and compare the answer, the result, with 0.3, right? 0.06 or 600ths is less than 0.3. And it's also less than 0.2. So it didn't matter which one you're comparing it to. If you're multiplying by a positive fractional number less than 1, multiplying by something less than 1 makes it smaller. So I should end up with something even smaller than 0.2. So that is the idea. All right. Well, I hope that gets you back on track, and depending where you are. But again, 7172. You should be coming in this class with some familiarity. Maybe we haven't seen why we multiply decimals the way we do, or maybe we haven't seen why we add them by lining them up. What's the reason? But I think now at this point in time, hopefully you do. All right, off you go.